Okay, we are going to talk in this video, we are going to talk about Fourier transform. We're going to touch upon the topic, we're not going to go deeply on it, okay? So we are going to understand what is the meaning of Fourier transform. If we have a function f that is absolutely integrable on the real line, so then the Fourier transform of this function, we call it like this f for the function, Fourier transform of the function, of this function is the function defined by, as you can see here, this is the Fourier series, Fourier transform of the function, okay, of this function in terms of a variable. This variable is omega, okay? So take care of this because we are concerned with having this Fourier transform to like change the variables of the function to another variable. Instead of using t, for example, we're going to use another kind of variable like omega, which is the frequency, as we are going to see in the example in a minute. Okay, so this Fourier transform of the function, which is going to be in terms of an independent variable called omega, and it's going to be the frequency, as I'm going to talk or explain in a minute. So it equals to the integration from minus infinity to infinity, the function itself, f of t, times this exponential function, which is e times e raised to the power minus I omega t. It's a complex term. Why this is exactly? Because it's better to represent the Fourier transform in this like the coordinates of the like real and imaginary numbers. It's better for understanding it to use this type of function. Okay, and we are going to weighing, or as if that we are weighing it by our main function and integrating from minus infinity to infinity. It's this integration is similar to what we have said before, like the summation, but now we are using the integration. Okay, because of the use of Fourier transform in applications such as signal analysis, this is one of the most and highly used applications for Fourier transform. So those who are interested in this, you can find more details about signal analysis applications related to Fourier transform. Okay, we usually use t for time as the variable in the defining integral, and omega as the variable of the transformed function. Okay, so this is the point, that t for the main function, however for the transform we use omega. You're going to find that later on this is very good for us, because in signal analysis, whenever that we have any signal, something like this, anything, we are going to transform this t, which is the time domain, to something else, which is, we are going to call it the frequency domain, and we are going to find that there are some frequencies, they are like having a high like spikes here. So these frequencies are going to be our concern. If for example in sound waves, for example, if we have some frequency that is making some noise, we can suppress it, right? We can remove it. So we want to know it first, and then we can like remove it. So this is one of the very simple applications, for example, especially for signal analysis, as I said. So we are going to use this, which is, instead of t or time domain, we're going to use it use the frequency domain. Okay, and engineers refer to omega in the transform function as the frequency of the signal f. So this is the frequency. The frequency is how many cycles in 1 second that is going to be there, okay, in a complete cycle for example. Okay, now let's jump into an example, because I'm going to touch on the topic, I'm not going to dig deeper into it. We will determine the transform of this function, which is e raised to the power minus c, the absolute value of t, with c a positive number. Okay, so we can put our function in this notation. We can say that e raised to minus c, absolute value of t, it equals to, simply, when t is larger than or equal to 0, then it would equal to e raised to minus ct, right? Because we have a minus here. And if t is less than 0, then it would equal e raised to ct. It's always going to be negative in this case. Okay, So if it's going to be t is going to be positive, then we put the minus sign. If t is going to be negative, we remove the minus sign. Okay, it's logic. It makes sense. Okay. Now then we're going to take the Fourier. This means that the Fourier transform of our main function with respect to another variable called omega, which is the frequency. It equals to the integration, as we said from the definition and explained, from minus infinity to infinity, the function itself, which is our function, times e raised to minus I omega t dt. Okay, so in this case we can like put our integration from two parts, from minus infinity to 0 and from 0 to infinity, right? Then we're going to have our function e ct. This is for the case where that this part of the function works, is less than 0, from minus infinity to 0. And then from 0 to infinity, this part of the function would work, which is this part, okay, e raised to minus ct, times e raised to minus I omega t, and this is the same. Then we're going to find that our integration, we're going to take t here as a common variable, and then we are going to lift up with this value between the parentheses, which is c minus I omega. In a similar fashion here, it is going to be the same, but minus sign is going to be here. It's a limited integration. We can use our skills, calculus skills, and we can like get the integration of this two terms easily. We are going to end up with something like this, and then rearranging it, we're going to end up with something like this: 2c over c squared plus omega squared. What is this? Yes, look to this deeply. It is 2c, okay, 2c over c squared plus omega squared. Well, where is t here? There is no t. There is no t here. But we have what? Exactly, omega. That's the point here. We have changed this e raised to the power minus c, absolute value of t, to something or a function that is only related to the omega. Okay, so that's the issue of the Fourier transform. This is the issue with Fourier transform. Okay, simply this is just touching on the topic because already you can find a lot of things and a lot of explanation regarding Fourier transform. I'm going to put some links for the explanation of the visualization of Fourier transform. It's very interesting, and I think that you need to understand it not only mathematically but at the same time visually. Thank you, and see you in the next video.